This presentation serves as a practical field guide for designing and operating AI agents that are reliable, performant, and secure enough for enterprise use. While demos are easy, moving to production requires addressing the enterprise tax, the rigorous governance and security standards required to serve a 50,000-person organization. The foundation of agent engineering is the core equation. Roughly 80% of production quality comes from the harness, prompts, tools, sandboxes, memory, not the model itself. For enterprise settings, a second equation applies. An agent that lacks auditability and multi-tenancy will not ship in a regulated environment. Before development, you must choose between a deterministic workflow, predefined paths, or an autonomous agent. Self-directed steps. The rule is to start with the simplest solution, workflow, and only add agentic autonomy when tasks are genuinely unpredictable. This slide also covers the build versus buy versus assemble decision based on your need for control and data residency. Moving to production requires paying the enterprise tax, which involves requirements unrelated to the AI model. This includes identity and access, SSO, multi-tenancy, data isolation, data governance, no-train guarantees, auditability, and compliance with regimes like SOC 2 and the EU AI Act. A production-grade architecture consists of a reliable kernel loop wrapped in an engineered harness. Key principles include a single core powering many surfaces, append-only state for auditability, and a clear split between the control plane, policy, auth, and the data plane runtime. The agent's heart is the observe, think, act, observe loop. It should be implemented as an async generator where the caller controls back pressure. A critical invariant is that every tool use must have a paired tool result, even if synthetic, to prevent corrupted transcripts. Tools are the agent's hands, mistake-proofed, poker yoke, with high signal outputs and instructive errors. The Model Context Protocol (MCP) provides a USB-C for AI, allowing you to build one connector that works across multiple clients with a centralized governance theme. Context engineering is essentially cost engineering, as input tokens represent 90% of the bill. Use cache stability, byte-stable prefixes, to reduce costs by up to 10x. Implement managed compaction at 80% budget and tier memory into working L0, episodic L1, and semantic L2 layers. Failure classification to distinguish between transient rate limits, retry, and permanent auth failures. Human intervention. Stuck detection identifies loops, while durable execution allows agents to resume from checkpoints rather than restarting. Security must architecturally break the lethal trifecta, the combination of untrusted input, private data access, and exfiltration capability. The rule of two dictates that no single unsupervised run should have all three. Implement defense in depth with sandboxing, egress control, and human-in-the-loop gates for high-impact actions. Design for multi-tenancy from day one by making the tenant ID the first dimension of every database row, secret, and cost record. Follow the per-session serial, cross-session concurrent model to avoid history races while maintaining throughput. Tracing must be performed on an append-only event log to capture decision patterns without necessarily reading sensitive content. Start evals immediately with approximately 20 real queries, using an LLM as judge and human reviews. Implement cost governance via per-tenant ceilings and model routing based on task complexity. To serve diverse enterprise needs, the agent should support 4 topologies: multi-tenant SaaS, single-tenant SaaS, self-hosted, BYOC, and hybrid split plane. A hard control plane, data plane split makes these movements possible via configuration rather than code forks. Enterprise adopt agents in stages: prototype, prove value, pilot, reliability, safety, production, multi-tenancy, SLA, platform, shared harness, and enterprise-wide compliance scale. Each stage requires different infrastructure. Do not overbuild for a stage 1 pilot. Scaling thousands of concurrent runs requires treating an agent run as a job, not a request. Use a durable queue and a stateless worker pool that checkpoint state. Scale on queue depth rather than CPU. And use warm sandbox pools to reduce tail latency. Success requires a platform team to own the harness, agent ops to manage SLAs and behavioral incident response, and a governance risk function to sign off on new tools. Prompts and tools must be treated as production code, subject to version control and eval-gated reviews. The rollout follows a 3-phase plan. Days 0-30 prove it, one high-value use case with basic sandboxing and evals. Days 30-160 harden it. Add the control plane, isolation, budgets, and security reviews. Days 60-190 scale it. Implement rainbow deploys, failover, and close compliance gaps. SU2. Avoid multi-agent swarms where a single agent suffices. Black box frameworks that hide prompts and silent retries that burn budget. Never use a superuser service account. Always act with the calling user's RBAC scope. Enterprise readiness is defined by the harness and trust surface around the model. By paying the enterprise tax deliberately and scaling in stages, you transition from a chatbot to a robust business platform